Alright, so we're going to pick up where we left off on Friday. Notice that on this sheet we are no longer simplifying expressions, but we're going to take the tools that we use in simplifying expressions and apply them in solving equations. So we have equal signs, and we're actually going to figure out what x is equal to in these cases. Now with problem number one is I'm kind of starting with the foundation. I want you to recognize that really we have kind of like a ratio. Everything on the left is in one fraction, everything on the right is in one fraction, and so when we get here we can use the tool of cross multiplication in order to find an x. So if I multiply, let's kind of go ahead and get started with this. This is a tool we're going to use on the first few, and then I actually may kind of get away from it on the bottom few and show you another way of thinking about these things. So if we multiply 2 times x minus 4, we would end up with 2x minus 8 is equal to 3 times x minus 2 is going to give us 3x minus 6. If I subtract over 2x and I add over 6, we're going to end up with negative 2 is equal to x. No big deal. And I will tell you that before we even go any further than this, that I don't believe this is as hard as the addition, some of the addition examples that I gave you guys. Alright, now on problem number 2, you'll recognize that this is not all in one fraction. So we have to add these two things together in order to get a ratio, and in order to do that we have to add have common denominators. So this is kind of an easier example. We'll notice that over here on the left we need a 2 and here we need an x. In order for us to add those things to get common denominators, we have to do the same thing on the top as we did beneath it, because really, and keep in mind we are not balancing equation right now with this, we're really just multiplying these things by a value of 1. And so that's going to give us 12 over 2x plus x squared over 2x is equal to 4. So good news, we have a common denominator, and we can say 12 plus x squared. I kind of prefer x squared plus 12, but I'm going to leave it right this here so I don't confuse anyone, is equal to 4. And so we can kind of cross multiply or multiply both sides by 2x, however you want to think about it. Those are doing the same thing. And I'll kind of bring my work up here. But what that gives us is 12 plus x squared is equal to 8x. And so in order for us to solve for x with a quadratic, we need to subtract this over, and I'm going to rearrange a little bit just so I feel more comfortable working with it. X squared minus 8x plus 12 is equal to 0. And while I know you can do this on your own, this is a one-way video, so I'm going to go ahead and tell you that's going to give us x minus 6 times x minus 2 is equal to 0. So x is equal to 6 or 2. Almost. Okay? This is where we have to keep in mind that we have a rule we've kind of ignored right now, and that is we are not allowed to divide by 0. So we have got to go back and check our solutions for extraneous solutions. And really, I'm going to do these things kind of independent. I'm going to say, okay, look, I noticed that I have an x in the denominator, so that means that x cannot equal 0. Well, the good news is that wasn't one of our solutions, so we are all good, and we can leave it all, we can turn all of it in. X is equal to 6 or 2, x cannot be equal to 0. Alright, again, we keep stepping up the way things look with complications. Number 3, we have got to find a common denominator before we add these two things together. And I'm going to begin to assume that we are comfortable with this, that we would multiply this by 3 and we would multiply this by x plus 3. And so hopefully we're at a spot where we're beginning to get more comfortable with this. So that will give us 30 over, and I'm going to leave these things separated, 3 times x plus 3 plus the top, I'm actually going to go ahead and distribute. 10x plus 30 over 3 times x plus 3 is all equal to 6. Let's go ahead and put all of this together. Notice that we'll have 30 and 30 and 10x on the top, so that's going to give us 10x plus 60 over, common denominator, 3 times x plus 3 is equal to 6. When we multiply by this denominator, or we think about it as cross multiplication, we're going to end up with 10x plus 60 is equal to 3 times 6 would be 18 times x plus 3, and we get 10x plus 60 is equal to 18x plus 54. Subtract over 10, subtract over 54, and we're going to get 6 is equal to, what would that be, 8x. So x is equal to 3/4. Now we've got to go back to our original and what we had here, and we will recognize that in the denominator we had an x plus 3 at one point, so it's worth making a note. X cannot equal to -3. Good news is that didn't show up, but let's go ahead and turn all of that in. Okay, so again, we're checking for extraneous solutions, but I think it's a healthy exercise to go ahead and list all things that x cannot equal to. Alright, just in showing you how I hope that our fluency has picked up, we have on this on the left hand side an x minus 5 in the denominator, so I'm going to call one x minus 5 over x minus 5 minus 8 over x minus 5 and set that equal to 3 over x. Right now I'm not even going to combine those. I'm not going to find a common denominator. Again, we're going to rely on cross multiplication, which means that we won't have to worry about that. So we can add these together. So x minus 5 minus 8 is going to give me x minus 13 over x minus 5 is equal to 3 over x. Cross multiplying, kind of bringing our work up here, we end up with x squared minus 13x is equal to 3x minus 15. Moving everything to the same side, x squared minus 16x plus 15 equals 0. Our factors are x minus 15 and x minus 1 is equal to 0. So solutions are 15 and 1. And I'm not going to do it in purple, but look back at our original equation. Notice we had, yeah, we'll do it in purple. That highlights it nicely. Notice we had x minus 5 and we have x, so this means that x cannot equal to 5 and cannot equal to 0. Good news is that's not one of the answers that we got, so we're good. And I'm going to use this right now as a stopping point. So take a break, stretch just a second, and get back to the second video or the second part of this, solving for rational expressions.